Hello students, today I'll explain about oxidation states of 4d series. Okay, so 4d series consists of elements, 10 elements from yttrium to cadmium. Yttrium atomic number 39 to cadmium atomic number 48. Okay, so firstly I'm writing the elements. So yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver and cadmium. Okay, so after this I'm writing about valence configuration. This is the valence configuration of these elements, that is yttrium 4d1 5s2, zirconium 4d2 5s2, niobium 4d4 5s1, molybdenum 45 5s1, technetium 45 5s2, ruthenium 47 5s2, rhodium 48 5s1, palladium 4010 5s0, silver 4010 5s1, cadmium 4010 5s2. Okay, so now yttrium loses all 3 electrons and gets a +3 oxidation state. Already we know if elements loses electrons, it gets a positive oxidation state. So positive symbol. So you can see here it loses 3 electrons and gets +3. And zirconium loses 3 electrons to get +3 and 4 electrons to get +4. Niobium onwards, you can see it has 5 electrons. So it loses all 5 electrons to get oxidation states from +2 to +5. Okay, next molybdenum. Molybdenum loses all 6 electrons and gets oxidation states from +2 to +6. Okay, next we have technetium. Technetium loses all 7 electrons and gets oxidation states from +2 to +7. Next we have a ruthenium. Ruthenium loses all electrons and gets oxidation states from +2 to +8. Okay, this is the element which shows highest oxidation state in this series. Next, coming to rhodium. Rhodium is having 9 electrons, but here onwards the decrease in size plays main role. So when size decreases, what happens? It won't shows ability to lose all electrons. So it won't lose all electrons, it lose only 6 electrons. So that is up to +6, +2 to +6, it exhibits oxidation states. Next we have palladium. Palladium shows +2 to +4 oxidation states. Next silver. Silver is the element which shows the +1 oxidation state, which is the lowest oxidation state in this series and which is stable oxidation state, +1 to +3. Cadmium. Cadmium exhibits +2 oxidation state. Okay, now so yttrium to ruthenium, all elements tries to lose electrons in order to get empty d orbital. So if it loses +3, all 3 electrons, it gets empty d orbital. It loses all 4 electrons, means it gets empty d orbital. So up to here you can observe all electrons will be loosed, and to get empty d orbital, in order to get stability, already we have discussed empty orbitals, half filled orbitals are completely filled orbitals are more stable because of equal energy and equal symmetry. Okay, now ruthenium exhibits highest oxidation state, that is already we have discussed. Rhodium onwards, oxidation states decreases because of small size, decrease in the size of the element. Now here elements of this series are more stable in the highest oxidation state when compared to 3d series. Why? Because they have high hydration energy. So high hydration energy means they are exhibiting highest oxidation states. So whenever they are exhibiting highest charge, their size will be decreased when compared to less charge. Okay, less charge means less positivity. So nuclear attraction will be less. High charge means high positivity. More positivity means electrons will be attracted towards nucleus and size will be decreased. Whenever size is decreasing, this element tries to absorb water molecules. So process of absorbing water molecules and releases energy. So whenever element absorbs water molecules, it releases some energy. That energy is called hydration energy. These elements will have high hydration energy. Due to that, they'll get stabilized. Okay, so hydration energy is more for the elements which are having highest charge, especially d block elements shows this property of hydration energy. Because of that, they'll be more stable in their highest oxidation states. So this is about oxidation states of 4d series. Thank you.